Good afternoon, everyone. We'll kick off shortly. Just checking to see if you can hear me okay on the speakers there. You could maybe type a comment in the chat box if you've got any issues hearing me. Let me know. Yeah, it looks like the microphone's relatively good, the feedback. There will be no video, it will just be a presentation, PowerPoint presentation that we'll be following along. Okay, so afternoon everyone, or good evening, and welcome to the Voltiman webinar series. My name is Christian Kiss, I'm from OSRAM, Australia, and I'm your host for the webinar topic today about how to choose quality LED products. If you have any questions, you can type them in the selection box below, and I'll try to answer them during the Q&A sessions at the end. So this is the excuse me. Sorry, I lost the slides somewhere in the upload, but basically the agenda topics I'll cover more or less. I'll talk about the advantages of LEDs, and I'll go through issues with low quality LEDs, general things to look for, addressing also things such as lighting terminologies, lumens, color, temperature, color rendering, what to look for compliance marks, choosing suitable LED products for your requirements, and then we'll talk a bit about some issues with LED products that are pretty commonly experienced, and then the end of the presentation will be looking ahead to the future of LEDs. So, general things to look for LED products. So, we've got the lifetime of LED, obviously, is a critical thing, which is basically one of the key selling points for LED products. The accepted industry standard for lifetime is basically the L70 B50 standard. So what that means is basically a lumen maintenance to 70% with basically a 30% degradation. So in a sample size of products, you'll have 50% of products where they'll basically degrade in lumen output by 30%. So that's that 70% lumen maintenance factor. The other things to look for when choosing quality products, obviously, would be to look for some kind of warranty, which really shows the manufacturer backs up or stands behind their product. So normally, most products out there are, I think, 3, 5 years and so on. It means they stand behind the product, and if something goes wrong, you can seek to get it replaced or some sort of solution from the manufacturer of the product. Buying from Australian-based suppliers is obviously recommended because you've got the compliance factor. So obviously Australian suppliers are bound to be selling a compliant product in the market because they're trading in the market. So if they're not selling a compliant product, they can also be liable for any issues that may arise if there's a non-conforming product. So there's a requirement for them to abide by those rules. And of course, warranty, you can go back to your supplier normally as the first point of contact if you've got any immediate concerns or issues with products that fail prematurely. Comparing products based on lumens and not wattage alone is basically the rule of thumb that you should look for when looking at LEDs these days. In the past, obviously with incandescent globes, we had wattages, and really there was pretty much no reference to lumens. So a lot of people, lumens is a bit of a foreign term, and I'll talk about that a bit more on some other slides. But basically, to compare products, the first thing to look for is lumens. So you can see on the packaging, one product A is the same sort of light output as the product B that you're comparing to. Wattage is still important in the second respect, because if you've got your lumens and your wattage, you can work out how efficient the product is with the ratio we call luminous efficacy, which is lumens per watt. The higher the efficacy, the more efficient the product, the more lumens you get out for the amount of power you put in. Checking if the product is dimmable or not is also important if you need to dim or don't need to dim. I mean, you can use non-dimmable products in dimmable applications, but they're normally a little bit more. But if dimming is critical, then you want to make sure that you're getting a product that is dimmable. Non-dimmable products can also fail with the electronic circuits not designed to cope with dimmer mechanisms. So it's another reason why it's important to be avoiding warranty if you use a non-dimmable product in a dimmer circuit. And looking for well-established brands are also pretty key in the market, so that you've got basically, excuse me, suppliers that have been around for a while and they've got a reputation they've built on. So you know you've got someone to turn to and speak to if you've got issues, technical matters, you've got product warranty concerns, and the like. Okay, so the advantages of upgrading to LED, obviously they're very efficient, which we sort of talked about already, in comparison to particularly old filament technologies and things like that. You've got the very long lifetime. The lifetime, obviously, product type from anywhere between 15,000 hours up to 50,000 hours normally. LEDs, you can have a consistent quality of light. They produce significantly less heat than other light sources. They still do produce heat, but it's not a. They don't emit thermal radiation like incandescent lamps, for example. So there's not as much wastage there. You get heat loss and things like that through the heat sinking. You've also got obviously a choice of color temperatures to choose from. So you can have warm LEDs or cool color temperatures, and you've also got high saturated colors such as RGB, red, green, blue LEDs, which is another advantage of LEDs, as opposed to your traditional technologies where you would have had to use a filter to basically get different colors or use various color tubes which weren't as high in their saturation of colors as LEDs are. LEDs are very quick switch on time, so basically as soon as you switch, the LED will come on, and there's no warm up time like fluorescent or compact fluorescent lamps, metal HID, metal halides, and so on. So they're very much ideal for sensor type scenarios. And they've also got a high resistance to frequency switching, which again lends itself to sensors and motion areas where there's high motion happening. Got a bit of a comment from someone saying there's a bit of an issue with the audio, so I'll try and maybe turn up the gain a bit to see if that makes a difference. Okay, so easy to dim and control. So it lends itself to smart lighting. So LED chips are relatively easy to dim, either with increasing or reducing the current, or you can also have pulse width modulation, which is basically a switching circuit, switching the light on and off very frequently in a very short space of time to make it appear that the light source is dimmed. LEDs are also a small point source, so they're ideal for compact luminaire integration. So you can have very compact fitting designs with a lot more freedom and design flexibility for designers and architects and so forth, and also the manufacturers, designers, and the luminaires themselves. LEDs, being a point source, are also easy to focus the light source itself with lenses and optics and things like that. So you can get excuse me, very narrow, very wide beam angles by using different types of optic lenses or reflectors and such. LEDs are also much more durable than traditional filament lamps with high resistance to shocks and vibrations. So again, that's another big thing, you know, just in garage doors and things like that, or in factories and places where there'd be a construction site where the vibration and movement. Okay, so in terms of common issues with LED, the issues with low quality LEDs, I should say, and there are some in the market, particularly if you're buying online, you have to be sort of buyer beware of what you're buying because you never really know what you're getting. So some products may be unsafe, and what we mean by that is literally you could get an electrical shock because there may be inadequate isolation between conductive paths and metal parts of the lamp, or soldering, things like this where there's joint where different parts of the lamp are not very well designed or constructed. And it's a very serious issue, obviously, because it can be lethal, basically. Some products are also, they have very poor light output. They're prone to premature failures. They may flicker. They can be color changing over time or color shifting over time, so they may start off looking okay, but they degrade very quickly because of a poor thermal design or using very cheap low-grade LED chips. LED retrofit lamps may not be standardized shapes and sizes, so in some cases they can be quite large and bulky and they may not really fit into well with standard fixtures that you already have existing. And obviously the biggest issue with any of those things is bad experiences with poor quality LED products will taint the perception of LEDs for end users in the market who may be just looking to try the technology. So why do we face such issues? In many cases, standards were either slow or haven't fully caught up with the rapid changes in technology. Currently, I mean, there are safety standards in place, and Australia's adopted several there from international standards, but there's no performance standard as such yet, such as MEPS, which is Minimum Energy Performance Standards, which exist, for example, in fluorescent tubes or compact fluorescent lamps with integrated ballasts. So for that reason, there really is no standard for the performance, and that's why you can get a wide variation of products out there. Unlike traditional lighting technologies, which also require full production equipment in factories, LEDs are relatively simple to produce in the way that they're electronic components that can be soldered to a PCB and put together in a relatively small sort of factory. So, I mean, you hear these stories of backyard factories in China and so forth where they're just assembling a lot of LED products. That's also why there are such issues. One of the other things is with when LED sort of came to the fore, a lot of the companies that supply electronic equipment in general started to get into LED as sort of opportunities to sell more product obviously to the market. So you had a lot of non-traditional lighting companies out there suddenly selling products such as LED lighting products where they may not really have any specialization in the lighting side of things necessarily, in the lighting terminologies and the things that are required to develop a good quality product. So this, for some reason, is a duplicated slide, so let's move on. Okay, so lighting terminologies, and again, these are just things to look for when looking at LEDs, and we already spoke about it. So what is lumens? It's also referred to as luminous flux. It's basically the total measure of light output from a light source in any given direction. So how much light is coming out of that product. So that's why we use that as the main reference when you're comparing product, because it's the most important. The unit of measure is lumens, abbreviated to LM. Watt, we all know what a watt is. It's basically a measure of power, how much power you used or consume to convert something from electrical energy, in this case to light, obviously for lighting products. So as I said before, with if you're comparing LED to incandescent, you can't use wattage because of the high difference in efficacy of the product. So looking to lumens, obviously, as I mentioned before, lumens per watt. Dividing a lumens by wattage will give you an efficiency or efficacy calculation. And just for reference, those are just some incandescent wattages and your sort of rough lumen outputs. So like a 40-watt incandescent lamp is about 415 lumens, 100-watt incandescents up to 1300 lumens for reference there. So they're very inefficient, and normally around sort of 12, 13 lumens per watt incandescent lamps. With LEDs, it can be up to and beyond 100 lumens per watt, and at the chip level, indeed, it can be even up to lumens per watt, depends on whether you look at it. We're looking mainly in my presentation at complete goods, complete products, so we're talking about luminaires or lamps, so that factors in control gear losses and things like that. So moving on to other lighting terminologies, correlated color temperature, sometimes abbreviated as CCT or even RA, which is the color rendering reference. Basically, is the appearance of a white light source. So whether it's a warm color like an incandescent lamp, or a really sort of bluish white color like you often can see in office lighting or in retail environments for the bright lighting effect. So, I mean, which is more suitable for various applications, obviously is a bit of a personal choice and also application specific. But with LEDs, obviously, you do have a choice there. Whereas in the incandescent halogen technology, due to the way the technology works, you're limited to warm colors. Color rendering index is another lighting term. So on top of color temperature, the color rendering index is basically really almost a percentage scale of how well a light source can reflect the different lights, different parts of the color spectrum on an average. So it's an average scale. So basically, an incandescent lamp was, and it still is, in the current standard reference light source. So that's got a color rendering index of 100. We used to have years ago fluorescent tubes that were halophosphor. They only had two types of phosphor, though only had a very sort of washed out look and had a color rendering of 60. So basically, the lower the color rendering, the poorer you're going to be able to perceive different colors under that reference light source. With LEDs, with most common ones, the color rendering is 80 or greater than 80. And there are some high color rendering LEDs that are 90 plus also for applications where you need that sort of thing, such as retail lighting, like copier printing and stuff like that. Another aspect which I guess is more, it's not always published for all manufacturers, is a term called SDCn, which is standard deviation of color matching. It's also in other terms called a McAdam ellipse, so they refer to the same thing. What that basically is in production of LED manufacturing, tolerances are unavoidable. So you get fluctuations in parameters such as voltage, lumen output, current, and so on. And to combat the issue that you get with this variation, they basically categorize LED chips into different bins. So the bins will be according to the color temperature, how much it varies in voltage and things like that, as I mentioned. They'll be separated into different bins. And basically the McAdam ellipse or a standard deviation step, it basically identifies how wide a variation is acceptable within that certain tolerance. So in this table here, you'll see one SDCn or McAdam step. You'll basically, the human eye cannot see a difference in color from one chip to another. In 2 to 3 McAdam steps, it's basically hardly any noticeable difference. Normally, a human eye won't detect a difference there. Greater than 4 is where you sort of start seeing the difference in color chip if you get a LED chip from one bin to a different bin completely. So it doesn't mean that all the LEDs within that, if they're 4 SDCn, for example, will look different. It's just that if you get two different categories and they happen to be on the extreme ends of within that ellipse, you can potentially notice a slight difference in color. And normally it may happen if you buy an LED from a batch and one point, and then 6 months later you buy the same LED, it might be from a different batch. You may have a slight noticeable difference in the appearance of the color temperature itself. For example, it might be slightly cooler or warmer, even though it's still 3000 Kelvin as an example. So 4 is generally considered to be quite good. 5 is also more or less standard. Anything above 5 is really, you can start noticing very obviously the differences. That's just a picture representation there of the differences. So with the 7th step, it's extremely noticeable that you can see a difference there, with one light source being very whitish and the other one being more yellow or orangey. Okay, so what else to look for? So obviously it's good to look for the regulatory compliance mark. So this is basically an important safety mark signifying compliance with Australia's safety and electromagnetic compatibility regulators. So that's all the state electrical regulators and ACMA, which is the Australian Communication and Media Authority. Products and packaging should bear this mark basically to show that they're complying with the Australian standard. So that's that triangle, that circle and a tick. On the 1st of March 2016, there was a 3-year transition period, which obviously started back in 2013, for suppliers to register on the ERAC national database called the EESS, which is the Electrical Equipment Safety Scheme. And at that time had lapsed, so as of 1st of March, that time had lapsed. So what that effectively meant is that all electrical equipment, if it was previously marked with the CTIC, had to migrate across and be now marked with the RCN mark. So effectively what that meant is from this date on, the CTIC had no legal status anymore. It's been phased out and the RCN's taken over to represent both EMC and safety. The CTIC only represented EMC specifically. So it was basically a consolidation of compliance markings to make it easier to just have one compliance mark rather than having to have a compliance mark and other markings such as certificate numbers and approval numbers or whatever on the product. Okay, so moving on to a slightly different topic. So choosing suitable LED product for your requirements. So LED technology, obviously everyone's seen the products in the market. You now pretty much have products to cover all facets of lighting in the market, be it flood lighting, domestic lighting, and obviously there's plenty of downlights and so forth. So I've just picked one example, a common example here of downlights and 2 options that are common in the market. So if you've got some downlights, your options are either to change to LED lamps without having to change your fittings, or change the whole luminaire to a complete integrated fitting with either an integrated driver or a driver that sits remote. That basically is one package. So next slide will go into a bit more detail about that. So the advantages of LED lamps is that you can keep the existing light fittings. And in many cases, you can keep the control gear in place as well in the case of an MR16, although I say that with a bit of a caveat, MR16 can be problematic because effectively there can be a bit of a limited compatibility with some lamps with legacy control gear in the marketplace. So you may have issues. It's in that case, and I'll talk about that a bit further because I've got some common issues towards the end of this presentation. The other advantage is obviously you can maintain a similar look and feel of the existing installation because all you're changing is the light source. So the lifetime, lifetime is still long, which is in the order of 15,000 to 30,000 hours, which is still 7.5 to 15 times the life of standard halogen lamps. And in comparison to halogen, it's 80+% energy savings. The other advantage, I guess you could say, is you can replace the light source, which is just LED, from the thing in the unlikely event that there's a premature failure that happens. The disadvantages of these LED lamps is the lumen outputs are typically in the lower end of the scale, so around about 350 to 500 is pretty common in the lumen output, and it's restricted due to the size and form factor of the LEDs that they have to conform to, and it's effectively how we can thermally manage the heat in the LED itself. The heat sink obviously can only be so big and would draw away the heat that is generated. So that limits how high the wattage can be and how high your lumens can be. Naturally, over time, as the technology matures and efficiencies gains are made, the lumen outputs should push the envelope a bit and get up higher. But that's typically what we're around about at now. You can get some higher lumen outputs on some products, but with those products, what you'll find is that they're either a very large form factor and may not necessarily fit into your fittings. So this MR16, as I mentioned at the top, lamps can have transformer compatibility issues. And that mainly relates to load issues, minimum load thresholds on transformers and things like that, because the LED load is quite small. So when you put an LED on a transformer that has a minimum load of 20 watts, it may not really like that very much, so it won't start up or it'll flicker and carry on. Generally, the lifetime of the LED lamps is shorter than complete luminaires, and that's again because of the form factor and things like that. Slightly outside of downlights, with LED lamps in general, it's pretty much expanded to be a good option to replace all your different base types. So you've got your Edison screw, your bayonet caps, or small bayonet caps, small screws, and so on, and your GU10 and GU5.3, which is your MR16 par 16 lamps. So LED lamps basically covering all compact fluorescent and even a lot of halogen incandescent markets nowadays. So going back to this scenario, I've chosen the option of the two. So the advantages of an LED luminaire is obviously the longer lifetime, which I spoke about, which is normally 30,000+ hours. Higher lumen outputs are available in this sort of package, so they're normally in the order of 800 to 1,000+ lumens. Obviously, depends a bit also on the cutout, but I'm talking about a very common 92 mil cutout for halogen downlights in this case. Dedicated driver means you get better performance, particularly with dimmer compatibility as well. You get obviously high energy savings compared to halogen if you have halogen in there. Wide beam angles are available, which gives you better uniformity, so not as many shadowing and hot spots and things like that. It's also a cost-effective solution now with the price of LED downlights coming down so much. If, for example, you go back to the case of an MR16 lamp and find that your transformer is not compatible and you have to change your transformers, then you're more or less paying the same or more money to get a new transformer plus a lamp. So it makes more sense to buy a complete downlight. The disadvantage of LED luminaires really is that at the end of life or in the unlikely event of a premature failure, you'd have to replace the whole luminaire. The light source itself can't be replaced because it's integrated inside that luminaire. So going on to common issues with LEDs. So I've already sort of spoke about this transformer compatibility with MR16 lamps, and really it's any low voltage lamps, including G4 bi-pin type lamps and MR11 as well. So again, because of low wattage load, some transformers don't like it very much. Basically, the electronics weren't really designed for one another. Now, when you think about it, halogen transformers are 12 volts AC. They were designed to run halogen lamps. So we're kind of making a technology that's a retrofit scenario. It's not going to be 100% foolproof, unfortunately, although manufacturers are continuing to always invest in improving the little driver technology inside the lamps to be able to make it more compatible with transformers. So we found that with every generation of LED lamps, typically your transformer compatibility is improved. Also, dimmer compatibility is improving, but currently, obviously, dimmer compatibility can be an issue with all types of LED products, but especially, I mean, the worst case scenario, I guess you could have, would be a halogen transformer and an MR16 lamp, because sometimes the technologies fight against each other and really don't lead to good results. But again, that's improving. In terms of what to look for with dimmer compatibility, you may not necessarily know what the legacy dimmers are in existing installations, so it's going to be hard to comment on whether the LED product would work. It would be ideal to be able to determine what it is before making an informed decision about upgrading the lighting. Overloading on dimmers can occur due to high inrush current of LEDs as well. So some people assume, obviously, with a low load on LEDs, that you can put a lot of LEDs onto, say, a 450 VA dimmer. What that often results in is that the dimmer ends up blowing up within a short space of time, and it's mainly to do with the high inrush current. I mean, it obviously can also be incompatibility and misfiring of the triac if they're not compatible and it's not maintaining the LED load properly. But yeah, overloading can occur as well. So as a rule of thumb, you should size the load based on what you're replacing. So roughly speaking, if you've got a 50 watt MR16 lamp equivalent, then treat it very similar to an 50 watt halogen load, and go with that and use a similar number of lamps per dimmer. Generally, universal or trailing edge dimmers work best for LEDs. So, but it's always advisable to check manufacturers' lists of recommended dimmers, which either may come with the product or could be on the website and so on, in case there are any odd exceptions there. One of the other issues that can occur is LEDs are susceptible to heat. So they're not recommended for fully enclosed luminaires with poor ventilation, and that's more to do with LED lamps in general. For example, the GLS style incandescent lamp replacements, they don't fare too well in completely enclosed luminaires or in hot environments where there's no ventilation at all, because the electronics just heat up too much and they end up resulting in premature failures. So what are some of the future trends with LED currently? With the movement of the Internet of Things, smart lighting is a major growing market at the moment. You've probably seen a lot of these products on the market. There's various right now. For example, OSRAM, we've got our Lightify product. Philips have Hue. Belkin have their Wemo as well. These are smart lighting products where you can control them with a smartphone app, be it with an Apple device or an Android device, and using Wi-Fi and things like that. These products use the Zigbee standard or Zigbee protocol, which is an established common protocol for home automation now. So it doesn't only include lighting, it includes other home automation things that can be controlled via Zigbee protocol. And Zigbee protocol is an open protocol, so that if you've got one Zigbee device, usually there shouldn't be any issue controlling it with other third-party devices. They should be interchangeable or intercontrollable, interoperable. New emerging products starting to also come about where they're just connecting direct to Wi-Fi. So in effect, they're sort of cutting out the gateway or bridge device, which is kind of the Zigbee main controller there. That's some of the things happening currently. So in the last couple of days, actually, Apple just announced also a big new focus on their Home app, which will be coming out of their iOS 10, which is the next Apple system update, I believe. That'll be a central point for controlling all smart devices that are HomeKit certified. And what HomeKit is Apple's proprietary protocol for using smart devices. It'll be Siri voice controlled, and users can create scenes like "Good night," for example, where you can speak, and if you set it up in such a way, you can have all the lights turn off and your front door and back doors or whatever lock up, as well as other smart things. I don't know if you can see it there on that example of the Apple presentation PowerPoint there in the bottom of the screen, little photo I've included, but they're the type of devices that home Apple control. So you've got smart locks, you've got security, you've got window shutters, air conditioners, so on. So this whole Internet of Things where everything's coming together and being controlled by applications from one device. So that's where things are moving. Currently, there's a lot of fragmentation in the market with different apps required to control different things. So this kind of will consolidate that. Rivals such as Google and Amazon have been working on their own systems as well. There's a lot of things happening in the background there, and the greatest barrier in has been standardizing protocols so that third parties can integrate the devices with various software and hardware. So, for example, the Apple HomeKit needs a specific it has Apple's proprietary system, so you need that specific chip which is compatible and it's included in each device, and obviously that will allow that device to be integrated into their system. Likewise, going back to the Zigbee, all the Zigbee amps will have a Zigbee module or controller in there that will allow it to work with the system. So it's really just everything coming together. There's a lot of fragmentation that means some devices don't work with other devices. So you just have too many apps to control too many different things. This sort of thing is, I think, trying to consolidate it all, and it's probably where the future is really heading in controllability of such devices, including obviously lighting. And so what else I've got here is this is an OSRAM thing. It's called OSRAM Einstein, and it's a relatively new technology that was just a project in Germany actually that they trialed it on. It's a location-based service which you can use for different apps that provides site-specific information and other services based on positioning data. The technology is integrated into the city lighting, so the lighting basically becomes a digital lighting service. So what that means is your light posts and things. There'll be an Einstein chip inside the lumen or the light fixture or the post as part of the lighting device, and therefore there's no need for extra infrastructure to install separate beacon devices and things like that. And what this does is basically the technology can be used for different purposes, point of interest, things such as city guides, shopping guides, museum guides, tracking and navigation services for office buildings, localized shopping services and special offers that services in a particular area may be offering. Because basically the way it works is if you're in a particular area or town or something, based on where you're located, and that's obviously detectable by these Einsteins in the Lumineers in the streetlights themselves, it will basically localize information based on that. And it's very precise positioning, which works independent of GPS or Wi-Fi. So that's something that OSRAM specifically has been working on in terms of new developments in smart lighting, things like that. So with that, that's basically the end of my presentation. So if you've got any questions or anything, you can just type in the chat box, and I'll see if I can hopefully answer them for you. questions that have come through. One is in relation to heat covers required by law for retrofitting. It asks, let me just go back there. As there are changes in the standard for recessed downlights, basically. Currently, and also to the wiring standards in Australia, which is AS3000. Currently, as to my knowledge, retrofitting, say you had a halogen downlight. If it's a do not cover downlight, I don't believe you need to cover the downlight, but you still need to maintain that 200 mil clearance around the downlight. But that's being reviewed now. There's a draft ASNZS 3000 circulating, so it's out for public comment, and I think some of these things will be probably more accurately addressed there. But to my knowledge, I think currently it's not mandatory. So there's another question. Do you think there's any inherent reason why MEPS LEDs have been introduced given their increasing popularity? Well, the biggest issue there has been realistic. I mean, one of it's obviously it's a government thing for them. They're already looking at MEPS for LEDs currently. So I mean, it's on the agenda. It's not like it's not. But one thing is government things take a long time to. They need to basically draft a regulatory impact statement and what the results of that will be, and then they have to shape up what standards and things like that will involve and how they'll implement it. But one of the other things has been, obviously, there's been, I guess, discrepancies whether to use ANSI, which is North American type standards, or CIE, which is more the European standards for LED performance, and they're looking at both options currently. I've seen some of the documentation and been involved in some discussions, so it will probably draw upon both ANSI and also European regulations. I mean, one thing that the government doesn't want to do is they don't want to legislate something based only on an Australian specific requirement, because in the global scale of things, Australia is a very small player in the market. So if we make it too hard to comply to standards, then we're going to really limit consumer choice for a wide range of products. That's one of the bigger concerns, I think. Okay, so what else have we got here? It's Australian standard to ensure when an LED fails within the light, the rest of the LED continues to work. As far as I know, there's no standard saying that if an LED chip, for example, fails, that the rest of the LEDs continue to work. I'm pretty sure the only standard is that if an LED product fails, it must fail safe, as far as I know. And so we've got some questions regarding failure modes of LEDs as well. Let me just quickly have a read. The chat box just went out of my vision there for a second. So there's a question of failure mode, experience with products and realistic lifetime figures. Can you comment on internal product design of better quality LED products? I myself can't comment too closely on the internal product design because my main sort of background in product management is more product marketing. So I don't have an engineering background. I'm not involved in the design aspect of it. So unfortunately, I can't comment too much there. In terms of failure modes, again, it's a difficult one to really comment on. You do obviously see premature failures, and it's look, it's hard to gauge because if it's only 1 and 2 lamps failing here and there, often the the retailer or wholesaler will take care of the matter, and it's never really investigated any further. In other cases, it's a matter of whether the end user or whoever complains about it, so you don't always hear about it. But I guess if you look at it from the point of view of the quantity or volume of product we sell versus the amount of complaints we get, it's really very minimal. So the failure rates are quite low. I don't have exact figures, but it'd be very low percentages, only 1-2% or less. So there's another quick question here. Let me just have a look. Are there any quality LED retrofit lamps with movement detection built in? Not. I haven't seen any personally. I know OSRAM are working on one for the European market. It's just a GLS style lamp. I'm not sure how well the movement sensor works in that because the sensor's located on one end of the bulb itself. So if it's not pointing in the right direction, it would not work well at all in my view. That's a product we probably haven't really considered for the Australian market in great depth at this point in time. Are there any high CRI consumer side products at present? Not really. If you're talking about anything higher than 90, most products are really 80 to 85, generally speaking, at least from OSRAM's point of view. There's relatively low number of products that should be 70 to 80. And I've got a final question there. Will the presentation notes, will the presentation be sent to the emails? I believe basically Voltman will send the follow-up and upload this as a video so you can review it and view it again. So if you've got any questions, maybe contact Voltman on that. But that should go out in the next sort of 1-2 weeks anyway with a follow-up email if you've participated in this webinar. So looks like that's all the questions for the moment. So yeah, thanks everyone for your time, and I hope you've benefited from hearing me talk about some products and standards and things like that on the LED and choosing quality products. Thanks everyone. Have a good afternoon and evening.